My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean, between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust and, in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, it's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. A bunch of super brainy scientists with even brainier computers. The first scenario: a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored superocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film, each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the North and South Pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle, where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and is called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down, and not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a megaflood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the Earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is.
An hour after people disappear, most urban areas will be left empty and quiet. Perhaps the sound of wind, falling leaves, or other natural sounds previously drowned out by city noise and traffic will be heard. The subways of many cities are protected from groundwater by a system of pumps. If there are no people to monitor such systems, most subways will flood within 36 hours. Due to malfunctions, sewage treatment plants will stop working, leading to pollution of rivers and lakes with wastewater. The water pipes in Detroit will become unusable, leading to the flooding of the city. Food in refrigerators will spoil. Raccoons and wolves will inhabit abandoned human homes. Major airports will be covered in rust and overgrown with ivy. Cruise ships in Alaska will sink under the weight of ice that accumulates on them. Lions from the San Diego Zoo will gradually escape, emboldened by the power outage of the electric fence around their enclosures. More and more black cats will appear on the streets of Rome and the Vatican. Rats and mice will consume all edible reserves and leave the cities. Plants will begin to grow in cracks in streets, highways, sidewalks, and buildings. More and more animals will notice the absence of people and flock to the cities. International Space Station will gradually decrease. Since no one will correct its orbit, the station will eventually fall to Earth and burn up. Along with it, digitized samples of human DNA will perish. A large part of the city's territory will be covered with a vegetation of lianas, grasses, and tree seedlings. The Red Square in Moscow will have a layer of soil and thick grasses growing, making the square completely green. Despite high levels of radiation, animal populations are increasing in abandoned areas. Plants have grown in many houses and buildings. Seawater will flood cities that were once drained by artificial drainage systems, such as London and Amsterdam. Satellites will begin to fall to Earth. Since no one maintained their speed of movement, they slowly approached Earth and eventually fell to the planet's surface. Wolves now roam freely around the Brandenburg Gate in Berlin, and wild boars will be seen in Paris. Human speech will be preserved in rare words that parrots have memorized during their years of living with humans. Snakes will not only reproduce at incredible rates, but also grow much larger in size. Their main prey will be rodents that have multiplied in the first years after humans disappeared. Many human-made structures will collapse within 100 years, primarily those with a large number of steel elements. Fruit Christmas cakes, thanks to their alcohol coating, will not only retain their appearance but also freshness. Most buildings will be overtaken by plants and animals, and the city will resemble more of a wild nature landscape. The period of nuclear fuel decay will come to an end, and as a result, dead zones around the ruins of nuclear power plants will once again become habitable. The last parrots that spoke human language may go extinct since they memorized human speech, but it is simply not necessary for their survival in the wild. All modern carriers of information that preserve human culture, laser discs, photographic film, paper, and the like, will turn to dust. Rebar inside concrete buildings, which are more durable than steel ones, will expand 3 times due to rust, causing the destruction of concrete structures. Most modern cities will be covered by a green blanket, and collapsed skyscrapers and buildings will become new hills. Manhattan will return to its former state before human settlement, with numerous streams and lakes. There will be almost no evidence of the existence of human civilization. Only powerful stone buildings that rely solely on the force of gravity will survive, such as Notre Dame de Paris. Of the products that existed during human civilization, only honey, especially in clay pots, and oil in wooden barrels, will be well preserved. Only a few stone structures will survive, including the pyramids in Giza and the Sphinx, almost entirely buried in the sands of the desert, and fragments of the Great Wall of China. By this time, a new ice age will begin on Earth. It is expected that the KEO satellite will enter the atmosphere by this time. Various pieces of space debris will collide with it during its descent, but this will not destroy the satellite. Eventually, it will fall into the waters of the world ocean. Remnants of spacecraft and satellite debris will float through space as the only reminder of human civilization.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all that is salt water from the world's oceans. There aren't any borders between the 4 oceans we've all come to know, but oceanographers and the world's countries did traditionally split these waters into 4 distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the 5th body of water. It's called the Southern Ocean, and 3 of the 4 original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space of the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it, and we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae could also be involved. Whoa, let me get my popcorn.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nios in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metal workers use. Duh. The air from the anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top. a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Moxstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future.
It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? every single building would have been destroyed and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line. In 1945, 5 TBF Avenger aircraft took flight for a routine training exercise around the Bermuda Triangle. In the middle of the exercise, the planes were struck by intense rain and heavy winds despite the clear weather forecast. The pilots became extremely disoriented and radioed the base to report that their navigational equipment had stopped working. The last thing the base heard was, "When the first plane drops below 10 gallons, we'll all go down together," and then static. The 5 planes and their 14 crew members were never seen or heard from again. On his very first voyage to the New World in 1492, Christopher Columbus sailed through the Bermuda Triangle. Columbus reported that one night when he was on the deck of the ship, he noticed a giant light appear in the distance, unlike anything he had ever seen before. Columbus looked at his compass for direction, and it gave off erratic readings. You might have noticed that the Bermuda Triangle doesn't appear on any world map. This is because official institutions refuse to acknowledge that the area actually exists. A popular theory suggests that rogue waves are responsible for the many disappearances. Rogue waves are called extreme storm waves by scientists. They occur when different weather patterns take place at the same time and cause large unexpected waves. Witnesses say that the waves look like giant walls of water. These waves could explain why ships go down fast and without leaving any trace. The Bermuda Triangle is home to some pretty intense and unexpected weather. Storms build up quickly and unexpectedly, then disappear soon after. If you blink, you might miss it. This could explain why few distress signals are issued. Pilots and sailors never saw the weather coming. No one knows exactly how many ships and planes have disappeared in the Bermuda Triangle. The rough estimate is 50 ships and 20 planes. Most of the time, the disappearances had no explanation and no wreckage has ever been left behind. Another bizarre theory trying to solve the Bermuda Triangle mystery comes from Charlie Berlitz. He insists that the area is home to the lost city of Atlantis. The missing ships and planes and malfunctioning equipment, according to him, were all caused by rays of energy let out by the special energy crystals that power Atlantis. While this sounds silly, Berlitz's theory was convincing enough that over 20 million people bought his book worldwide. In the year 1800, a large sailing vessel called the USS Pickering departed from the U.S. on its way to the West Indies. The ship sailed into the Bermuda Triangle along with its 90-man crew and was never heard from again. The USS Pickering was the first ever confirmed ship to vanish in the Bermuda Triangle. It's believed that the ship was taken out by a storm, but because no wreckage was ever found, we'll never know for sure. When the TBF Avenger planes went missing, a massive search operation was conducted. Boats and planes searched the Bermuda Triangle for any signs of the aircraft. One of the boats searching was a PBM-5 Mariner airboat. The airboat took flight at 7:27 p.m. and called in a routine radio message 3 minutes later. Then, it was never heard from again. No trace was ever found of the rescue airboat or the 5 Avenger aircraft. An enormous investigation was launched into the disappearance of all these vehicles, but nothing was ever discovered. This particular area of the ocean is one of the most heavily traveled shipping routes in the world. Some skeptics believe that this fact solves the mystery. Statistically, the busier the area, the higher the frequency of accidents and disappearances. While this makes sense, it's not the frequency of disappearances that's responsible for the mystery of the Bermuda Triangle. It's the lack of explanation or wreckage found. On the ocean floor, decomposing organisms let off large concentrations of methane gas that gets trapped under the water. This gas can build up until, boom, it ruptures. The gas surges up to the surface and erupts. If a ship was in the area of one of these ruptures, the water would become much less dense and cause the ship to sink rapidly and without warning. Scientists believe this could be the cause of the many disappearances in the Bermuda Triangle. While this theory makes a lot of sense, it doesn't seem too likely. The U.S. Geological Survey has stated that no large releases of gas are believed to have occurred in this area for the past 15,000 years. The ocean floor is made of rocks containing a lot of magnetite. It's more like iron. Magnetic fields react to high concentrations of magnetite on the ocean floor, which may start a sort of conflict between the two. It can often lead to various weather anomalies and, as a result, navigation issues. And, naturally, any changes in the ocean floor or the Earth's magnetic fields influence the Bermuda Triangle a lot. Since the magnetic field is constantly moving, it might be also taking the Bermuda Triangle with it. Now that people know where the triangle is, it's easy to avoid it. It supposedly moves eastward together with the magnetic poles, but scientists still can't answer where exactly it will be in a couple of years. Some people blame all the disasters on the extraterrestrial paranormal activity. Others suppose it's all about raging natural phenomena. There's another triangle in Lake Michigan. Just like the one near Bermuda, the Michigan Triangle got its shady reputation for some disappearances. The first recorded one dates back to 1679. A large vessel, one of the largest of that time, set out on an expedition. Yet once it got in the sinister triangle, it never came back. Much later, an aircraft disappeared in this triangle. The skies are usually very clear there, but back in 1883, some people witnessed abnormal things in the area. Some claim to have seen large blocks of ice falling from the skies, and the crew even managed to save one as hard proof. Meanwhile, the Pacific Ocean Mystery Area is another sinister triangle. Off the south coast of Japan, not far away from Tokyo, there's a sea where plenty of ships met their doom, disappearing without a trace in these waters. They call it the Devil's Triangle. Some scientists believe the cause of anomalies is the environmental changes. Also, there's a really high concentration of methane hydrates on the bottom of the ocean in the Pacific Triangle area. You're deviating from your original course and sailing in the wrong direction. There's the Caribbean Sea near the triangle, peppered with small islands. The seafloor here isn't deep. The ship can get in shallow waters. and now the ship is stuck on a shoal, and you have no idea where you are. If this were the 21st century, the ship's captain would be able to reach the shore using GPS and other modern navigation. But the most interesting thing is that the compass would work correctly this time, since the magnetic North Pole hasn't already coincided with the true one for a long time in the territory of the Bermuda Triangle. The agonic line is somewhere far away from here. There are no problems with navigation now, but for some reason, this is where ships disappear. In fact, not just here. Throughout the Atlantic Ocean, there are places where many more ships were gone. The Bermuda Triangle is not even in the top 10 of such places. One of the main reasons why many ships are lost here is that one of the most popular shipping routes in the Atlantic passes through the Bermuda Triangle. And the more ships in one place, the more shipwrecks. Simple probability. Then, it just starts getting weird. Other theories say that there's a space-time rift in this region. Ships and planes fall into this rift and end up in the past or the future. But for some reason, there's not a single proof of this myth. There's no reason to think that the rift is hidden somewhere here. The base of an extraterrestrial civilization is located in the Bermuda Triangle. Visitors from other galaxies steal sea vessels along with the crew, so no one finds the wreckage of the ships. This is also a popular myth that has no scientific justification. The Kraken lives somewhere in the triangle. It's a huge squid that sinks ships and also is a legend that sailors tell each other. However, gigantic squids live in the depths of the ocean. They can grow to the size of half a train car, but no cases have ever been recorded where they sunk a large vessel. And in the area of the Bermuda Triangle, they have never ever been seen. People in the past didn't know about the existence of these creatures, so when they saw them for the first time, they described them as huge, terrible monsters. Giant squids are some of the most elusive creatures on Earth, and scientists had to use sonar equipment to find them. They don't like to leave the dark depths and are likely to be afraid of the sound of any ship. So, that should squash the squid as a suspect.